Hello students, in this lecture we are going to understand about the physical quantities, their unit and their measurement. This topic is very useful for the students preparing for NEET and JEE. First we understand about the physical quantity. Physical quantities are those which can be measured and governed the laws of physics. Different types of physical quantities tells us the different properties of system or body. For example, velocity tells us how fast the system or body is moving. Acceleration tells us how fast velocity of body or system is changing. The amount of a physical quantity is called their magnitude. We get it when a physical quantity is measured. If anyone purchases 10 kg of sugar, then here 10 kg is the magnitude of mass of the sugar. On the same way, if a person purchases a rod of length 10 meter, then here 10 meter is the magnitude of length of the rod. To understand the process of measurement, first we define units. Unit of a physical quantity is certain and well-known amount. For example, kilogram is the unit of mass which is fixed everywhere and well known. Meter is the unit of length which is fixed and well known. A physical quantity have large number of units. Some are smaller in size and some are larger in size. For example, gram and kilogram both are the unit of mass, but gram is smaller in size comparison to the kilogram. The size of kilogram is 1000 times to the size of gram. Meter and centimeter both are the unit of length. The size of the unit meter is 100 times to the size of the unit centimeter. Now we can understand measurement. Actually, measurement is the process of comparing a physical quantity with their unit. If a person measured a mass of an object and he found that it is 10 times to the size of 1 kilogram, then the magnitude of mass of that object is 10 kilogram. Here 10 is the numerical value and kilogram is the unit used in measurement. Similarly, if a person measured the length of a rod and he found that it is 5 times to the size of 1 meter, then the magnitude of length of the rod is 5 meter. Here numerical value is 5 and the unit used is meter. Now it is clear that the magnitude of a physical quantity is the product of numerical value and the unit used in the measurement. If we consider that numerical value is small n and the unit used is small u, then the magnitude of physical quantity is written as capital Q equal to small n into small u. If a person measured a physical quantity by using two different units of different size, then in this case the magnitude of physical quantity remains unchanged and numerical value of the physical quantity become inversely proportional to the unit used. Therefore, in case of unit conversion from one system to another system, we can use the formula N1 U1 equal to N2 U2 or N2 upon N1 equal to U1 upon U2. There are large number of physical quantities in physics, therefore it is very difficult to study their units separately. To resolve this problem, anyone can select a set of physical quantities which are independent to each other. That is, a quantity from that set cannot be attained in terms of the rest physical quantities. Such type of set are considered as a base quantity. Therefore, large number of sets of fundamental physical quantities is possible. For example, a set of force, mass and time can be considered as a fundamental or base quantities because there is no interrelation between force, mass and time. Momentum, length and time also can be considered as a set of fundamental physical quantities because momentum cannot be attained in terms of length and time. Momentum, length and time are independent to each other. Force, velocity and time also can be considered as a fundamental set of physical quantity because these are independent to each other. But speed, length and time cannot be considered as a set of fundamental quantities because speed can be attained in terms of length and time. Speed equal to distance travelled upon time interval. Distance travelled is the type of length. There are large number of sets which can be considered as a fundamental physical quantities. But there is a set which is accepted internationally as a fundamental physical quantities. In this set, base quantities selected are mass, length, time, electric current, temperature, luminous intensity and quantity of matter. Rest physical quantities can be derived in terms of these 7 fundamental physical quantities. Therefore, rest quantities are also known as derived quantities, except plane angle and solid angle. The unit of rest quantities also can be attained in terms of the unit of these 7 fundamental quantities. For example, speed equal to distance travelled upon time taken. Therefore, unit of speed equal to unit of length upon unit of time. Therefore, unit of speed are centimeter per second, meter per second, kilometer per hour, etc. Acceleration equal to change in velocity upon time interval. Therefore, unit of acceleration equal to unit of velocity upon unit of time. This gives unit of acceleration meter per second square, centimeter per second square, etc. Force equal to mass into acceleration. Therefore, unit of force equal to unit of mass into unit of acceleration. This gives unit of force kilogram meter per second square, gram centimeter per second square. In international system of unit, the units of mass, length, time, electric current, temperature, luminous intensity and quantity of matter are kilogram, meter, second, ampere, Kelvin, candela, and mole, respectively. The unit of plane angle and solid angle cannot be attained in terms of the units of base quantities. Therefore, these two quantities are also known as supplementary quantities. The units used for plane angle and solid angle in international system of unit are radian and steradian respectively.